All right, Washington Middle School, we are at Fred Meyer, and we're gonna search for some percents. Let's take a little walk around and see what we can find. You know that I love the outdoor gear, and Columbia Sportswear is great. And today, Columbia Sportswear is 30% off. Well, not only do I love Columbia Sportswear, you know that I need hats because I gotta cover up this bald head. So this hat, what do you think? Looks pretty good? Looks pretty good? Yeah, so if I'm gonna save 30% on this hat, what is the normal price? The price is usually $25, $25 for this hat, but today I'm gonna save 30%. How much am I going to save off my $25 hat? Well, let's work on that. Let's go to the whiteboard and work on that together. So when we're talking about percent problems, we're talking about mathematical stories that involve percents. We are looking for one of three things. We are looking for a part, we're looking for a part, or we're looking for a whole, or we are looking for a percent. Okay, so when I went to Fred Meyer just now, what do I know? Yeah, I know that the percent was 30%. We knew that the hat was 30% off. What else do we know? Yeah, we know the whole amount. The whole amount, the original price was $25. So what are we looking for? We're looking for the part. That's right, we do need to find the part. And we can do that using any of our four methods that we've learned. We've learned bar diagrams, we've learned ratio tables, we've learned double number lines, and we have studied equivalent fractions. And we are going to work on one of those four, but we're going to work on all of them, and then you decide. What do you want to do? That's the nice thing about math. You know, there's all kinds of ways that we can model our thinking, and in math you can just choose which one do I want to use to model my thinking. So I'm going to go through all of them. You choose which one you like best, because you really just need to use one as you're doing these. So we're going to start with bar diagrams. So our hat originally cost $25. And we are looking to find out what is the percent that we are going to get off of that hat. If it originally cost $25, we're going to break that up into increments of 10%, because that's our easy one. We have 30 is the same as 3 tens. So we're just going to break that up in half and then make 1, 2, 3, 4 lines, 1, 2, 3, 4 lines, and we have increments of 10%. How many of these are we going to shade in? For 30%, we're going to shade in 3. Now, what is the value of one of these squares, of 10% of $25? Well, 10% of $25 is just 25 over 10. 25 divided by 10, I can just move my decimal back one place and move this decimal back one place, because we're just dividing by 10. When we multiply by 10, we add a 0. When we divide by 10, we move the decimal back. So 10% of $25 is 2.5, or $2.50. So what is 30%? What is 30% of $25? Well, we just need to do 250, and multiply by 3, and we get 0, 15, and 7. We move our decimal back 2 places. So 250 plus 250 plus 250 equals $7.50. So I'm going to save $7.50 on my hat. All right, so we can do this with a bar diagram. What are we going to do next? A ratio table. Let's do that together. All right, so we have two categories. We have the price is $25, the percent is 100. We are mixing our part. 30% is what? We're missing that part. Well, we need to scale down 100 to 30. So 100 divided by what equals 30? Well, I can just do 100 divided by 30 is what? Well, 100 divided by 30 is 10 thirds. Because 100 divided by 30 is 100 30ths. 100 30ths is the same as 10 thirds. Because we can just take off divide both by 10, we get 10 thirds. Now I can just multiply or divide 25 by 10 thirds. Well, what is 25 divided by 10 thirds? Well, I get the same as 25 divided by 10 and multiplied by 3. It's divided by 10, and then the inverse of 3 is multiplied by 3. 25 times 3 is 75, and 75 divided by 10 equals 7.5. So my answer again is $7.50. Ratio table on this problem specifically might be a little bit hard. You might not be ready to multiply and divide by fractions yet. It depends on the problem. Sometimes it's a little bit easier. Let's do a double number line and see how that works. All right, double number line is my favorite method for working with percents. Maybe you're going to find it that way too. When you're working with percents, double number line is a great way. You guys have been working on these with your other ratios, but we're just doing it out of a ratio of 100, always. So the percent line always ends at 100. Always ends at 100. You can keep going above 100. You can go to 150%, 200%, 5,000%. But when we're working with something below, then we're going to go to 100. We're going to 100, and what do we know about 100%? Well, 100% of 25 is all of 25. So we're going to put our $25. $25 is 100%. So our price when we have 25, when we have 100%, it is 25. So you normally go to the store, you buy the hat, it's going to cost you $25. But we're asking, what is 30% off? How much am I going to save on that hat if I save 30%? Well, I'm just going to scale down to 10%. So I'm going to divide 100 divided by 10. 100 divided by 10 equals 10%. So I'm scaling that double number line down to 10%. So if I'm dividing the bottom number by 10, then I'm going to divide 25 divided by 10, and I am going to get 2.5. 25 divided by 10 is 2.5. So I've got 2.5 is 10%. So my question doesn't ask me what 10% is. I need to scale up, and I can skip 20% and go right up to 30%. What is 30%? Well, it's pretty easy. Instead of just writing 30% in, I'm going to go to 20% first. So 20% is going to be 2.5 plus 2.5 is going to be $5. And then 30% is going to be 2.5 plus 2.5 plus 2.5, so $7.50. Now I can just keep on going. If you ask me what 40% is, then I can just say 40% is $10 because $7.50 plus 2.5 is 10. Is $22.50 and we get 100% being $25. We can just scale that up and just skip count when we're using our double number lines. That's why I love using those double number lines, because it just gets it right in your head like that. But we can scale down by 10% and then scale up multiplied by 3. 10 times 3 is 30%. 2.5 times 3 is 7.5 or $7.50. So again, we've got that part, $7.50. What's our last method we're going to use? Equivalent ratios. These are fun. Equivalent fractions. Alright, so we've got two ratios. We have our 30 over 100, so 30% over 100% is equivalent to what our price, or price that we're saving, over 25, the whole. Because 25 is the ratio that's equal to the whole. 25 and the whole are the same, so 25 is equal to 100%. And 30 is going to be equal to that ratio of the price. So all we have to do on this one, we're going to scale down 100 divided by 4, and we're going to get 25. So then we are going to just scale 30 down, 30 divided by 4, and what are we going to get? Well, 30 divided by 4, 4 goes into 37 times, 7 times 4 is 28, and I get 2 left over, and I need to add my decimal. So 5 times 4 is 20, and I get $7.50 or $7.50 is my part 7. No matter how I do it, I get $7.50 is the amount that I save on my hat. Alright, you can use any of these methods, or you can use all of them. Go back and forth, get comfortable, get it in your brain how you are working on your part, your whole, and your percent on each of your problems, and then pick a couple of your practice problems and do those, exit ticket, and then I will see you tomorrow.